All right, we're going to go ahead and get started. It's 3:15. My name is Jeff Mieleff, and I'm a program manager in the Office division in the Exchange product group. And we're here today to talk about virtualization in Exchange 2013. I am, amongst other roles, the virtualization program manager for the Exchange group. So I'm the guy responsible for setting all of our support criteria, support policies. I work with a number of teams within Exchange as well as cross-group with the Hyper-V team to build best practices guidance. And I also work with some of our partners in the virtualization space with some of the third-party hypervisors that we support also to provide feedback on best practices guidance and make sure that all of us kind of in that community are providing the best possible guidance to our customers and making sure that that you have a successful deployment of Exchange in a virtualized environment. So I have a number of things to cover today. Should have time for questions. If not, like I mentioned in my sizing session earlier, I'm going to be at Ask the Experts tomorrow evening for that entire time. So feel free to stop by if you have any questions about virtualization that we can't answer today. That's the royal we that I can't answer today. And alternatively, if you just want to come up and grab a business card, feel free to reach out to me over email. I'm more than happy to connect that way as well. So in terms of what I want to cover today, I'm going to briefly go over some common reasons that we hear in talking to customers about why and why not virtualize Exchange 2013. To be clear, we absolutely support virtualization for the Exchange product, and we have for a couple of releases now. I know there's been confusion over the years about that, and in what ways we do or do not support virtualization. I actually had someone come up to me in the Microsoft booth on Tuesday evening at the welcome reception and ask if we supported an internal Microsoft employee and asked me if we supported virtualization for Exchange. So obviously there is confusion out there. Hopefully none of you walk away being confused at all today about what we do and do not support from a virtualization perspective with the Exchange product. That's certainly one of my key goals in delivering this information. So we'll talk about why and why not, because there's no simple answer for whether or not it makes sense. I'll go through some of the specific virtualization supportability guidelines for Exchange 2013 and how they have or have not changed from prior releases. Some of you out there today who currently virtualize Exchange may think that a lot of that is quite familiar. In general, we've tried to keep it as consistent as possible. So I'll call out the specific things that have changed version to version. And then we'll talk about sizing recommendations. When you think about building a virtualized deployment of Exchange, you certainly need to think about how to properly size for it. And there are some specific changes that you need to make, particularly around CPU requirements, when you think about building a virtualized Exchange deployment. And then last, I'm going to spend a little bit of time talking about problem areas. One of the things that I work on in my role is critical escalations from large, angry customers. I actually love coming to events like this because I get to talk to happy customers generally. But the flip side to that is when there are problems with some of our really big customers who pick up the phone and call Steve Ballmer and give him what for about the fact that their virtualized Exchange deployment isn't working, I'm the one that gets sent to and try and clean up that mess a bit. So I'm going to talk through some of the common themes, I guess, around what causes those problems typically, with the goal of helping you to avoid them. When you think about how to tune your hypervisor hosts, how to manage where you place virtual machines, Exchange virtual machines across multiple hosts in a private cloud or some other type of server farm that you might have. So that'll probably be the bulk of where we spend our time. And then at the end, any time left over, happy to take questions and or give you a card to take with you. So out of curiosity, those of you in the room today, how many of you are virtualizing Exchange currently? Okay. How many of you are on Hyper-V? Okay. VMware? Something else other than those two? Anybody? Anybody? All right. Usually I see like one or two hands, but I guess not today. All right. That's just kind of for my own information. I always like to ask those questions just so I kind of have a sense of where people are deployed today. when I think about where we're going to invest in terms of guidance. So what are some of the reasons that I typically hear for why virtualize Exchange? A big one is around server consolidation. There's certainly a perception that when you virtualize workloads, you're going to be able to take better advantage of hardware, reduce the overall server footprint in your data centers, save some money that way, right? That's a very common reason that customers and partners recommend virtualizing any sort of workload, and Exchange is certainly part of that. Doesn't always work, but there are certainly potential significant benefits around server consolidation with hypervisors, absolutely. Homogeneous infrastructure is another common reason. The idea that you can optimize deployment, right? From a hypervisor perspective, rather than thinking about particular types of hardware, particular hardware configurations that I need to deploy workloads on, in a virtual world, regardless of the physical hardware that I'm deploying on, I can create virtual machines that have the exact same processor configuration, the exact same memory size, the exact same storage presented, and I kind of hide the differences in physical hardware behind the scenes from the workload. That's kind of nice. Makes sizing deployment potentially a bit easier. From a management perspective, I also get some potential benefits. I get depending on where you invest in some of the tools that are available in virtualization platforms, whether it's Microsoft System Center products or some of the third-party offerings in this space, you potentially get a nice single console to manage your entire data center infrastructure, or a set of consoles that work together to manage your entire data center infrastructure. Rather than having tools for managing your hardware, where it might be one tool from one vendor, another tool from another vendor that don't talk well together, different tools for managing different aspects of storage, servers, etc. That's certainly a potential benefit and can save some money around operational expense. Monitoring, same thing, right? I have a common platform that I'm using, and I can monitor that all as a unit. And respond to events in a common way. Hardware utilization also kind of falls into this server consolidation theme as well. This is really talking about taking advantage of underutilized hardware. So it's very common to oversize deployments of a given workload. You can certainly do it with Exchange, where you end up with more hardware than you actually need. And in a virtualized deployment, that's fine. You can just deploy some other workloads on that same hardware, take full advantage of what you've bought, and potentially save some cost, rather than having these sort of unique islands of servers that are associated with a particular workload that you may have more servers than you need in those islands. Cost is also another typical reason for doing this. There's certainly a perception that virtualization is going to save money. And it often does. Not always, but often. It doesn't always with Exchange, and I'll talk about some of the reasons for that in a minute. But it can save money in some cases, absolutely. And actually, one reason that's not up on the list here, that I hear more often than any other reason, is because we virtualize everything as a management sort of edict, right? We've just decided organization-wide, we're going to virtualize. And so there's no discussion whatsoever. We're just going to go down that path. That's a very common reason. I think that's an unfortunate reason. I think that there really ought to be a definite perceived or basically a definite benefit coming from the process of virtualization, some definite features coming out of that investment in the virtualization stack. So why not? Why wouldn't you virtualize? The Exchange product group years ago used to be very anti-virtualization. I would argue that these days we're probably a little more indifferent than against. It's certainly an option, but these are some of the reasons, historically that Exchange has argued for not virtualizing, and I think many of them ring true today, and may apply to some of your deployments. Complexity is a big one. We've tried over the last couple of releases to drive a lot of the complexity out of an Exchange deployment. You think about what we've done in 2013 in bringing managed availability into the product, basically taking some of that automated response that might have come from System Center historically, building it into the product so that the product can actually do a little bit of, I hesitate to use the term because it's kind of a loaded term, but self-healing, right? It's noticing where problems are occurring and taking action to make things right again. By doing that, we're removing the need for some of those extra pieces that sort of bolt on to Exchange or have bolted on historically. That drives down complexity. When you virtualize, you're adding complexity to the solution, right? You're adding an extra layer between Exchange and the physical hardware. You're potentially adding a bunch of additional, well, some of the things we just talked about on the previous slide. Management applications, monitoring applications, things that you wouldn't necessarily need otherwise. They may bring you benefit when you think about virtualizing all of your applications, but just virtualizing Exchange on its own, virtualizing is definitely going to add complexity. It's very hard to argue against that. So there's a balance there that you need to think about. Additional deployment steps, this is fairly clear, right? You're having to deploy something else. If I just have physical hardware and I want to deploy Exchange, I install Windows on my hardware, I install Exchange. I'm kind of oversimplifying that, but in an ideal world, that's all that it takes to get Exchange up and running. With a virtualized deployment, obviously, I have that extra layer that I need to think about, whether I'm deploying a third-party hypervisor, whether I'm configuring Hyper-V. I have to make that happen. That's additional time. I'm adding an additional management layer. Yes, that is a homogeneous management layer across all of my applications, but it is something additional that I'm adding that may or may not be new to the organization, requires some training, et cetera. Same with monitoring. There is a performance impact to virtualization. Don't let anyone tell you otherwise. I know that over the years, there have certainly been marketing claims that virtualization is free or Exchange runs better virtualized than it does on physical. Not true. Absolutely not true. There will always be a CPU impact because you're putting something in between the physical hardware and the application, and that is the hypervisor. There's a cost to that hypervisor. In Hyper-V's case, it's about 10% CPU. In VMware's case, they have some published guidance on what to expect from that product. Basically, all of the hypervisor vendors provide some guidance on that CPU cost. So be aware of that. You are adding cost from a performance perspective, which eventually translates to hardware cost when you choose to virtualize. 10% may be negligible in the grand scheme of things, but if you have a large deployment, 10% of a large deployment is potentially a large number. So it can be a consideration. And then another reason is certainly workload unsupportability. You go look at the Exchange 2003 guidance around virtualization, and it's fairly clear that it doesn't make sense to virtualize Exchange 2003 if you care about supportability. That's less of an issue certainly today, or not really an issue at all with Exchange 2013. But there are some workloads that do not support being virtualized today. And then cost, right? Hypervisors, depending on which you choose, have a cost in terms of purchasing, support, et cetera. So there really is no good answer about whether or not to virtualize Exchange. Like I said, from an Exchange team perspective, I think it's fair to say that we're pretty indifferent today. I think what we would like to generally recommend is that you pick the simplest solution possible that gives you what you're looking for in terms of your business requirements for your messaging solution. We think that physical is often the simplest solution, but obviously there are other considerations that are going to come into play in making this decision. Are you already virtualizing every other workload that you have today in your data centers? If so, deploying Exchange in its own little island, not virtualized, may not make a heck of a lot of sense. However, if you could deploy it for a third of the cost or a fifth of the cost, by choosing a different storage methodology than you might end up using if you virtualize, well, maybe that might tip the scales towards physical. It's going to be a decision that everybody in this room needs to make on their own. And given that the vast majority of you raised your hands when I asked who was virtualizing today, I'm assuming most of you are going to continue virtualizing Exchange. We don't at Microsoft, I'll tell you that, either for our own internal deployment within MSIT, our dog food deployment for the Exchange team, or Exchange Online, our very large deployment as part of Office 365. We actually find that it's significantly cheaper for us to operate those services as deployments on physical. So, it really depends on specific considerations. And a lot of those savings for us come from using JBOD storage, going backup-less. It basically comes down to the storage architecture. And because of that storage architecture, there are a lot of benefits that we would not be able to take advantage of on a virtualized platform. Right? We're not using shared storage. We can't easily use live migration, as an example, to move workloads between servers because of that data being sort of locked to a particular server. So the benefit from virtualizing is very minimal, if it's even there at all. And that's really why we choose to remain on physical internally. So we absolutely support virtualization of Exchange because we recognize that it makes sense for some customers. It doesn't make sense for everyone, but that's fine. Just like we support multiple storage technologies sitting behind Exchange, we absolutely support this and test it very well. So let's talk about 2013 specifically. So 2013 came out at about, shortly after Windows Server 2012, which from a Hyper-V perspective adds a whole bunch of fantastic new features. And there's more stuff coming in Server 2012 R2 as well. Hopefully you've been learning about some of that at TechEd. In Server 2012, ignoring the R2 changes, there are a couple of specific limits that have been removed that are very relevant for Exchange. Probably the biggest is the 4 virtual CPU limit per virtual machine. Historically, for Exchange, I've had a very hard time arguing for deployment on Hyper-V because of that 4 virtual CPU limit. Basically meant that many customers ended up deploying a lot more Exchange servers than they would have had to otherwise because they could only size up to 4 virtual CPUs. The sizing guidance for Exchange 2010 might have told them they needed 8 or 12 or some number like that, but instead of being able to actually take advantage of that number of CPUs, they had to deploy multiple servers with only 4 each. It's the reason that many of you, I'm assuming, are on other platforms. It's a very common reason that customers have gone to other platforms. That limit is gone. I'm very happy about that. And it's extremely exciting for us to be able to move beyond that. So we actually think that, that Exchange on Server 2012 Hyper-V is a great place to be. Server 2012 also has an increased per virtual machine memory limit. If any of you were in the sizing session earlier, we talked a little bit about some of the memory increases in Exchange 2013. We will certainly take advantage of the increased memory per virtual machine. That's another limit that would have potentially caused a problem for us, but absolutely doesn't in 2012. So we think that from a kind of a better together story, if you plan to virtualize Exchange 2013, doing it on Server 2012 is a great way to go. And I'll talk about why that is from a storage perspective in just a minute. There's a particular feature in there that we're really happy to be supporting. We do think that from a Hyper-V perspective, Hyper-V is absolutely the most tested virtualization platform for Exchange. We run thousands of virtual machines on Hyper-V every day. Many of those are built out from scratch every day. Essentially, all of our daily test passes for the Exchange product for Exchange 2013 as well as previous releases are running on, you could think of big private clouds that are basically allocating test machines on a very, very fast basis. And all of our developers have access to that cloud to be able to build test machines and validate specific changes before they go and check in a change to our source management system. We have a pretty strong feedback loop, actually, between Exchange and Hyper-V as well, which is something that's a little harder to do with some of our partners outside the company. And what you could think of as kind of an ongoing engineering relationship between the two teams. So we certainly share details on product direction and make sure that we're as aligned as possible in the future around feature investments. So we love Hyper-V. from a virtualization perspective, we think it's absolutely the best platform for Exchange. So would love it if some of you who aren't on Hyper-V today would consider looking at it in the future. So let's talk about what's supported and what's not. Like I said earlier, if you're on 2010, some of this may look very familiar. So when you think about hypervisors, these are basically the versions of Hyper-V that are associated with the OS versions we support for Exchange 2013, as well as third-party hypervisors via the Windows Server Virtualization Validation Program. That's a mouthful. The SVVP. That's where support for VMware, Citrix Zen, some of our other partners come from. There's a great website that's part of Windows Server Catalog that describes particular versions of those third-party hypervisors and which versions of Windows they're supported with. And that's where you can go essentially see what hypervisors what third-party hypervisors are supported with Exchange. In terms of Exchange roles, we only really have 2 of them now, so this is kind of easy. They're both supported. You can virtualize CAS, you can virtualize Mailbox, and you can virtualize the combination. I would argue that combining the 2 from a virtualization perspective is absolutely the way to go, same as you would for physical. Right? Keep it simple. Just deploy both CAS and Mailbox as a single unit. As I mentioned in the sizing session earlier, there's really only 2 kind of minor reasons for not combining Mailbox and CAS in 2013. And there's one around certificate management and some potential costs associated with that, depending on the certificate authority that you use. And the other is around use of Windows Network load balancing, not being compatible with that type of deployment. But in general, we would absolutely recommend virtualized or physical deploy multi-role. From a storage perspective, we still continue to require block level storage. And in general, the same requirements since Exchange 2010. There's a little asterisk there at the end that I'll explain in a second. So there is a minor change, but in general, same requirements that we had in 2010. From a host-based clustering perspective, and what I'm talking about there is clustering multiple hypervisor hosts together so that virtual machines can fail over from one physical hypervisor host to another. We absolutely support that as well. I'll talk about best practices around that and why you might not want to just use that as a high availability solution, but we do support it, absolutely. From a migration perspective, talking about moving live workloads between physical hypervisor hosts, same thing, absolutely supported. And we also made a change a little over a year ago to support running jet stress in virtual machines. It's a relatively new thing. I'm going to keep mentioning it for at least another year because I know there are some folks that aren't aware of it. We do absolutely recommend running jet stress, physical or virtual, before you go into production, just to make sure that your storage is good to go. It's absolutely a best practice, very easy test to do. It's a free tool. Run it, please. There's a URL down here at the bottom, and that provides a link to the TechNet webpage that lists out all the specific details of what we do and do not support for 2013 virtualization. So what's up with the asterisk? We've made a decision in Exchange 2013 to support the SMB 3.0 protocol for accessing VHDs in virtualized deployments using Hyper-V. So what this essentially means is that you can build a fairly inexpensive shared storage deployment using Windows Server 2012 file servers that could be standalone, could be clustered. We'll talk about what some of those different options look like in a second. Could be using storage spaces, potentially, to build large pools of storage in a very cost-effective way. And you can use that storage as a host for your Exchange VHD files, whether that's the system drives, the location for the Exchange install directory, or for Exchange data, mailbox databases, Q files for transport. Totally fine. We actually love this. We think this is a great way to take advantage of some of our design principles around Exchange with large mailboxes and large, cheap midline SAS or SATA drives, while still being able to, because it's shared storage, to take full advantage of the hypervisor platform. Still being able to do things like live migration without having to actually live migrate potentially terabytes of mailbox data in that process, right? You can just live migrate a mailbox server and switch access to the storage behind the scenes, and I'll just do that all using SMB3. That is totally specific to VHD files. We don't support pointing exchange, like an Exchange physical server, at SMB 3.0 file shares for storage of mailbox databases. It won't work. I can tell you right now, the commandlets that you use for creating mailbox databases, new mailbox database, will not allow you to put in a UNC path to that mailbox database. So this is all about behind the scenes, basically mapping VHD files in Hyper-V to SMB3 file shares. We're not changing the supportability around NFS or previous versions of SMB. This is just SMB 3.0. And it doesn't have to be specific, or is not specific, to the Windows implementation of it. There are storage vendors, many of our partners, who have already or are in the process of producing storage products that provide an SMB 3.0 interface that can be utilized for this. So many of our partners down on the show floor provide storage products that have an SMB 3.0 target. So what does this actually look like? There's a few diagrams here that I kind of stole from some of the Windows documentation around this feature. The goal here is really to kind of describe the different options from a scalability perspective and some of the flexibility around this type of a deployment. So on the left side of the slide, what I'm showing there is a very simple deployment with 2 Hyper-V hosts and a file server cluster that could actually be just a single Windows file server, and a couple of shares that are divided up amongst those 2 drives. Very simple, right? I'm just basically exposing some drives as SMB file shares, and Hyper-V is accessing those, accessing the VHD files on those shares, exposing that as storage to Exchange. In the middle, I get a little more complex. I have some shared storage between 2 Windows file servers. That shared storage can be accessed by either of the file servers, and those file servers have effectively the same shares available on them, so that I can actually fail over between the 2. If I lose file server 1, I can actually, through continuous access, continue to get to the data on that shared SAS storage. Notice it's SAS, it's direct attached storage potentially, and be able to survive that server failure. Much better from a high availability perspective than the option on the far left. And then on the far right, I get a little more complex. I actually have a fiber channel storage array, potentially a big SAN if I wanted to, with multiple file servers, in this case 4, where I'm spreading out the shares and actually scaling out even farther for performance reasons. So I can be extremely small in my design here, or I can scale up quite dramatically. And it's effectively the same functionality that Hyper-V is taking advantage of, regardless of how big you want to go. So we love this because, like I said, we can really take advantage of the large low-cost disks that are available out there today. Talking about 3, 4, soon much bigger terabyte drives that are available as SATA or midline SAS, and build a shared storage deployment using those drives at a much more reasonable cost than we've been able to historically. So why not NFS? This is a typical question that I get, because I know there are a number of folks out there who use storage products that have NFS implementations, and it would certainly be nice to be able to utilize those with your hypervisor. There's 2 reasons, and sort of an overriding reason. So NFS is a standard. It's not an implementation. Just like SMB is a standard and not an implementation. We're just a little more familiar with the SMB standard. There are multiple implementations of NFS. There historically has been one in Windows. I don't know if it's in 2012 anymore. I haven't looked recently. I'm willing to bet that our NFS implementation is not that great compared to some of the other ones out there. We've historically had 2 issues with NFS: performance and reliability. Performance is fairly straightforward, right? If we can't get the throughput that we need to provide Exchange with the resources that it needs, end users are going to feel that. It's very easy to talk about end user impact of slow disks, right? That's going to be, in the olden days, that would have been pop-ups in Outlook, where Outlook was blaming the Exchange server for being slow, essentially. That's going to be slow actions in OA, clicking on a folder, waiting for a while before the folder view actually refreshes. And that's going to be delays in mail getting sent and received. From a reliability perspective, I actually care way more about reliability in this area than I do about performance. We've actually seen a number of cases of database corruption on NFS file shares in virtualized deployments. And that's really the reason that we choose not to support it. There are potentially NFS implementations that we could support, but it's very difficult for us to effectively test every single one of them and talk about very specific versions of specific vendor products that are and are not capable of providing this ability. So that's where we are currently with NFS. Another area of confusion that typically comes up is around migration. And I think the guidance that's out there on TechNet today is really the reason for the confusion. There's a bunch of stuff out there about cold boot that doesn't really mean anything. And I'll explain what the confusion is. So from a migration perspective, we absolutely support live migration, vMotion, any other technology that you would use to migrate a virtual machine while it's running with no user-perceived downtime, as long as that migration is done with the workload online the entire time. If the migration is done by effectively taking a point-in-time snapshot of the machine, committing that to disk, and then moving over to another physical host and starting up, that's not supported. For the same reason that we don't support taking snapshots of an Exchange production virtual machine. Exchange doesn't play well with the notion of kind of going back in time. That's really the big challenge with Exchange. Anytime you have a distributed system where you're replicating data between multiple machines or managing cached information over time, like where the active copy of a user's mailbox database is, or which server is responsible for some particular aspect of the system. When you have individual machines in that deployment that stop at a point in time and come up at a previous point in time, that's a bad thing. And it leads to, in Exchange's case, oftentimes reseeding, potentially a lot of manual intervention to get things back online. So that's the challenge. Hyper-V has a great example of a technology here that we don't support. It's called quick migration, and it does exactly what I was describing. And that's taking basically saving state for a virtual machine to disk, and then bringing up that virtual machine from saved state on another machine. That's not supported. Live migration and vMotion, all good. So what do we not support specifically? So in 2013, we are choosing to not support dynamic memory, memory overcommit, memory reclamation, any sort of technology that's going to change the allocation of memory to Exchange behind the scenes. There's a lot of different terms for this depending on the hypervisor product that you have deployed. Hyper-V uses the term dynamic memory, so that's the one I lead off with because we're most familiar with it. But VMware has a number of technologies in this area that allow you to more effectively utilize memory on a physical host, and the other hypervisors in this space do as well. Exchange does not do well with memory being taken away underneath the covers, and I'll actually describe what happens visually in a few minutes, so you can get a feel for that. In 2010, as a best practice, we absolutely recommended that you not use these technologies. In 2013, really because of the number of support incidents that we've had related to these technologies, we're not supporting them at all. We're just saying, if you have an issue related to Exchange performance, reliability, whatever, where you have deployed Exchange on a virtual machine and you're using these technologies, you're going to have to effectively reproduce the problem on a virtual machine where you're not using those technologies for us to be able to support it from an Exchange perspective. So that's what that means. I mentioned that we didn't support hypervisor snapshots, and that's the going back in time piece. Absolutely great from a test lab perspective. I could not get my job done without hypervisor snapshots. They're the coolest thing ever. Being able to deploy a 16 node DAG, all in virtual machines, and have hundreds of databases replicating, be able to go tweak something just to see what happens and not worry about having to rebuild everything from scratch and then jump back to a point in time before I made the change, that is fantastic and a huge time saver. Fantastic for pre-production, for test, whatever, not supported for production. That's the key. Differencing and delta disks are the storage technology that sit behind hypervisor snapshots. And for the same reason that we don't support hypervisor snapshots, we don't support differencing and delta disks. We also don't support deploying applications on the root. This is fairly straightforward. If you're a VMware shop, this is hard to do. If you're using Hyper-V, this is a little easier. And basically what we're saying is don't deploy Exchange VMs and then go and deploy SQL on the root of your Hyper-V host or some line of business application. And the reason for that, you can actually try this in a test lab. Go run some performance-intensive application on the root of your Hyper-V host and see what the impact is on your virtual machines. If you run that same workload on one of your virtual machines, you'll most likely see that Hyper-V does a really good job balancing between the needs of those virtual machines. But if you actually run that performance-intensive application on the root, Hyper-V doesn't do such a good job balancing those needs. And Exchange is generally going to be the loser in that scenario. We don't support significant processor oversubscription. What I mean by that is configuring a lot more virtual CPUs for your virtual machines than you actually have physical CPUs. Now, there are reasons absolutely to oversubscribe processors. You may be running P2V operations where you're taking physical hosts and creating virtual machines out of them in an automated way. And the P2V process may take whatever the processor configuration is on the physical host and mirror it in virtual. And you may end up consolidating a whole bunch of VMs on a physical host and have oversubscribed processors. That's fine. That's absolutely fine. The key for Exchange is we don't want to have a lot more virtual CPUs than we actually need to operate. What we want to have happen is for a normal sizing process to occur. So you actually know what the CPU requirements are for each of your Exchange virtual machines, and you size them appropriately within the hypervisor. I talked in the sizing session about a very important reason for not having a lot of additional CPUs. It's the reason we recommend not using hyperthreading in a physical deployment. There's a very large memory hit that you get on a per logical CPU basis in 2013. So having, just because you can configure 32 virtual CPUs for your Exchange servers doesn't mean that you're actually going to get the benefit you think you might. We would much rather have you, based on the sizing guidance, realize that you need 12 CPUs or 16 CPUs and configure those virtual machines for that number. So that's really what that's about. Hyper-V also has a new feature called Replica that is kind of a nice complement to Exchange. So Replica is doing something very similar to what SQL and Exchange do in terms of replication of data. Both SQL and Exchange have this concept of log replication that's used to replicate databases between multiple servers. Hyper-V Replica is doing the same thing, but it's replicating virtual machines. So the benefit there is that you can take really any Hyper-V virtual machine, replicate changes to that virtual machine to a secondary location using that log replication technology, and if you have any sort of disaster in your primary data center, you then have disaster recovery for any application that you could virtualize, which is pretty much everything these days. So any application that doesn't have disaster recovery technology built in, you can get DR for via Hyper-V Replica. We have a number of challenges with Hyper-V Replica and Exchange. We don't currently support it. That may change at some point in the future, but it's not currently supported. What we recommend is basically using a DAG and use the log replication that's built into Exchange to get disaster recovery out of the product. Happy to go into more detail on that if you have specific questions around the background on that, but keep in mind at the moment, Replica and Exchange are not compatible with each other. So, sizing recommendations. So I mentioned that there's around a 10% CPU hit for Hyper-V. I'm not going to talk specifically to the guidance for the other hypervisors that we support because it changes over time. We've been fairly consistent with the 10% guidance for Hyper-V over the years. It hasn't really changed all that much. But we recommend absolutely checking with your hypervisor vendor to understand what their specific guidance is. And it can be workload specific. The impact of virtualizing Exchange might be different depending on the implementation of the hypervisor than the impact of virtualizing SQL, as an example. So be aware of that. They typically have best practice white papers for major workloads like Exchange, SQL, SharePoint, et cetera. The role requirements calculator actually has this 10% calculation built in, as well as the ability to change that 10% number. So if you get a different number from your hypervisor vendor, there's a server role virtualization yes or no option in the calculator. So you just set that to yes. By default, that's going to add 10% to your CPU requirements. So if you're using Hyper-V, you're good. If you need to change the number, if you scroll down a bit on the same input page, there's a hypervisor CPU adjustment factor. It's set to 10 by default. Just change that to whatever the percentage guidance is that you intend to use, and the calculator will do its magic. So fairly straightforward to size that. In terms of other resource impacts, we don't really have any specific guidance around memory for virtualized Exchange. There's certainly been a lot of attention paid in Server 2012 to NUMA, given that there's some functionality in Server 2012 that exposes NUMA memory topology to virtual machines. Exchange isn't NUMA aware. We don't really care about NUMA topologies. There's nothing in the Exchange product that's going to go look at that information and do anything differently. So NUMA's great. It's not going to do a heck of a lot for Exchange from a performance perspective. It's going to do some great things for applications that are optimized for it. SQL's a great example of that. And the Windows operating system makes some much better decisions about how it operates given NUMA topology information. So by all means, we recommend following hypervisor best practices in terms of exposing NUMA topology information to virtual machines and trying to contain virtual machines around NUMA boundaries. There is benefit to doing that just because of the way the operating system beneath Exchange operates. But don't expect that Exchange is going to specifically benefit from that. Just be aware of that. From a storage perspective, straightforward, right? Same as physical. You need to optimize for low I/O latency and high availability. Those are the keys for Exchange. We need to keep latencies beneath our published thresholds, and we need to make sure that if storage has an issue, that Exchange is going to respond in an appropriate way to remain available. From a networking perspective, we also don't have very strong guidance either on physical or virtual. There's a number of very cool features in the virtual world around networking, and the ability to virtualize networks, take advantage of the extensible switch, et cetera, in Hyper-V. By all means, take advantage of that functionality, and the goal here is really availability and performance. So if there are features that allow you to isolate workloads that are running on the same physical hosts in order to guarantee bandwidth or latency to specific applications, or utilize quality of service settings, that's fantastic. Exchange can certainly take advantage of that. We are certainly dependent on network latency when you think about things like log shipping between DAG nodes, as well as client access, guaranteeing some sort of quality of service or bandwidth and availability between clients and server. So in general, the overall goal here is for you to size in the same way that you would for physical or virtual. And then if you are going to deploy virtual, think about the changes that need to be made to that physical sizing guidance to apply it to a virtual environment. That's increasing the CPU requirements by 10% for Hyper-V or whatever the hypervisor guidance is. That's thinking about where virtual machines are going to live. And I'll talk about that in a minute to make sure that you're not impacting high availability through a virtual machine placement. If you are going to be co-locating Exchange with other virtual machines, and in general, you're probably going to be doing that because you want to take full advantage of hardware. Reservation options in the hypervisor are really the way to make sure that Exchange gets what it needs. We do a really good job in Exchange through our sizing guidance of predicting what you're going to need in a worst case failure situation, basically at peak. And what we want to do from an Exchange perspective is guarantee that those resources are available to Exchange. And you can do that through reservations, whether it's memory reservations, CPU reservations, quality of service around network, potentially quality of service around storage. We're starting to see more features in that space right now. So as a best practice, we recommend not overcommitting resources for Exchange. You can overcommit all you like with the other workloads that are running in that environment as long as those other workloads are okay with it. But reservations allow you to overcommit everything else effectively and guarantee resources to Exchange so that it can run at optimal performance. That's the key. I know it sounds like we're kind of being the bully and wanting to hog all the resources that are available. But at the same time, when Exchange is not performing well, it's one of the first applications that people complain about. We know that from our own experience internally, and I'm guessing you've felt that as well if you've had problems with your Exchange deployments in the past. We want to make sure that Exchange is running at its best possible performance. Users per host is an interesting discussion around virtualization. So if you're virtualizing, you're probably buying big servers. Lots of CPUs, lots of memory, lots of storage. And that's oftentimes how you're taking advantage of some of that server consolidation, reducing the number of physical servers in your data centers. Those very large servers are capable of running a very large number of Exchange users. Absolutely. Not necessarily a good idea. The key there is high availability. What happens if one of those physical hosts goes down that's hosting a few or many mailbox virtual machines? How many users are going to go through a reconnect process? And what's the impact of that going to be on your Active Directory infrastructure, on your load balancers, on your CAS infrastructure, as all of those reconnects happen? I've seen many, many cases where different levels of that infrastructure, those are kind of the three main pieces, but there's other pieces as well that can be impacted, where one of those three falls over as a result of a failure that impacted a large number of users simultaneously. And this is one of the easiest ways to make that happen. Build a large hypervisor host, deploy a lot of active users on it. What you want to do is take advantage of that large hardware, deploy the minimum number of Exchange mailbox VMs that you can on it, and use as much of that additional hardware for other workloads as you can. Basically, spread out your mailbox virtual machines as much as possible. Take advantage of as many physical hosts as you can, and that helps you with high availability. In the same way that in a physical world, we recommend more smaller servers to take advantage of that sort of scale-out approach. So we recommend planning for a small number of mailbox VMs per host, and like I said, use the remaining capacity for other workloads where possible. So, problem areas, how to avoid them. These are the sort of the main buckets, and I've already touched on these a little bit, but I'm going to drill into them just a bit more. These are the main buckets of areas where we typically see problems these days. So, we like to talk about failure domains. And when we use the term failure domains, what we're really talking about are aspects of your infrastructure that can impact high availability. So any sort of shared infrastructure that you have, regardless of physical or virtual, you could think of as a failure domain. Right? If I'm using a shared storage infrastructure across 15 mailbox servers, and I only have a single fiber channel switch between those mailbox servers and my shared storage, if that switch goes away, I lose all of my mailbox servers. Right? The whole notion of, I'm assuming I'm using a DAG there and I'm doing some replication. The whole point of having a DAG is completely lost because of that one failure domain. When you have the capability of deploying multiple mailbox servers on a physical host, you have the capability of creating more failure domains that you need to plan for. So understanding what's going to happen as each, basically as each potential device in your overall infrastructure fails at any point in the future is really critical to guaranteeing high availability. Everything fails. Exchange has bugs, absolutely. Windows has bugs, all software has bugs, and all hardware eventually fails. Some of it takes a lot longer than others, but everything fails at some point. So the whole point of this is plan for failure, understand when each of those components fails, can you stay up with Exchange? That should be the goal, always. And if not, it's a trade-off, right? What is the impact going to be, and understand that impact, and make a note of that. There may be some cases where it's the right decision to allow that failure to happen, whether it's a cost decision, whether there's business needs, business requirements that don't exist for a particular deployment that might result in a short failure being okay. It depends on your specific situation. We absolutely recommend not placing multiple mailbox database copies on the same physical infrastructure, regardless, right? Regardless of physical versus virtual. If you're building a DAG, we would certainly not recommend that you deploy all of the database copies for your DAG on the same SAN. Not a good idea. Spread it out across multiple SANs, multiple sets of switches. Same thing for virtualization. If you're going to deploy a DAG, don't deploy multiple copies of the same database on the same physical hosts. Make sure that you're spreading that out. Dependencies of Exchange are also critical here. And I've actually seen cases where witness servers were being hosted on the same physical, basically virtualized witness servers were being hosted on the same physical infrastructure as Exchange DAG nodes. And that can be okay in some scenarios, but you really need to think through, like I said, from a failure perspective, what's going to happen when that physical host goes down? Are you going to be able to bring up other DAG nodes? Are you going to be able to handle a failover properly? Active Directory is also another critical piece of this. If AD goes down, Exchange is dead. We need AD to be running properly, running healthy. So if you're going to virtualize Active Directory, absolutely follow the AD team's best practices for virtualizing AD and make sure that it is healthy and able to perform at the needed level. So I mentioned host-based failover clustering earlier in the supported section. What we're talking about there, like I said, is really the notion of having multiple physical hypervisor hosts that are clustered and able to deal with a hardware failure or a network failure at the hypervisor level. So if I lose a physical host, I want the virtual machines that are running on that physical host to be able to come up automatically on another physical host. That's fantastic technology. It's great. It doesn't really provide what we in the Exchange team consider high availability. The reason for that is that when you have that failure, the virtual machine is going to come up on another physical host from cold boot. It's going to have to go through the Windows boot process. Exchange is going to have to start up. That's not a quick operation, right? What we actually recommend doing is combining this with DAG if you want to use this technology. So create a database availability group, get your high availability from the database availability group, and take advantage of host-based failover clustering to bring the failed DAG virtual machines up on a usable host so that you can then get replication healthy again. That's the key, right? The high availability comes from the DAG because it can respond very quickly to a DAG node going down. And then host-based failover clustering helps to get replication back online and the overall DAG healthy again. That's the key. So I call this belt and suspenders, right? It's using two methods to kind of keep things up and running. So we talked a little bit about dynamic memory earlier. Dynamic memory really is great with Exchange for lab environments, where you don't necessarily care about performance. You're just testing functionality. You want to make sure that something's going to work. You're not running actual load against the system. Dynamic memory is fine for that. And we run that in our test environments at Microsoft to be able to better consolidate workloads, consolidate virtual machines, and get more virtual machines running on physical hosts. So the challenge for Exchange is that if memory gets ripped out from underneath us via ballooning methods, essentially, where the hypervisor will go in via a driver that's running in the virtual machine and basically ask for large contiguous blocks of memory, forcing the running workloads on the virtual machine to shrink their memory utilization. Because of how Exchange allocates memory for database cache, where we're basically picking a size at runtime and using that amount of memory for the entire duration of the life of the Exchange service, what you end up with is that database cache most likely being served out of the page file, which is really not a healthy place to be. Means that a lot of those database requests that were not going to disk because they were being served out of cache are now actually going to disk, but going to a disk that's probably not very performant. Probably wasn't designed for high throughput. The system drive, most likely, where your page file lives, or maybe a separate page file drive if you've done that, but that's pretty rare these days. So to avoid that, static memory configuration is the way to go. And I actually have a chart here that kind of describes how that looks. So the first set of data points that I have on this chart represent RPC average latency. This is my favorite counter, performance counter in the Exchange product. What this is basically the average amount of time that it's taking the Exchange store or the Exchange RPC client access service. There's actually two counters with the same name at different levels in the stack, to respond to an individual remote procedure call, which is what Outlook uses and really what all of our workloads now use to access store to get data or to change data. So every request essentially that's coming into Exchange is an RPC. This is showing over time the average amount of milliseconds that it's taking to respond to those requests. So you can see in the middle, we see a pretty significant increase in RPC average latency. This is the memory available bytes counter, which corresponds pretty nicely with a drop around the time that the RPC average latency counter started spiking. So if we look in a little more depth, this counter is the transition pages repurposed per second counter. It's a great performance counter in Windows that represents the level of memory pressure that the overall system is under. So if you have applications that are starting up and asking for a whole bunch of memory, transition pages repurposed per second will typically spike. In old releases of Exchange, when we used to change database cache dynamically and shrink or grow it based on the way the system was performing, this is actually the counter that we were using behind the scenes to decide whether or not we needed to shrink the database cache. We don't do that anymore. We pick a size and use that size from startup on. But what this shows is at that point in time, in the about a third of the way into the graph, the system went under significant memory pressure. And then if I overlay pages output per second over that, pages output per second can represent a bunch of different things. But for the purposes of this discussion, it's going to represent the number of memory pages that are being written out to the page file. So I'm doing a whole bunch of page file writes while I'm under memory pressure, which makes sense. I have something on the system that's asking for a bunch of free memory, and so I have to write a bunch of the current memory allocations out to the page file to be able to satisfy that. Makes sense. The next two counters are working set. These counters represent the amount of physical memory in the total case that all of the processes on the physical machine or the virtual machine are using at a point in time. So there's a concept of virtual memory, obviously within Windows. This is the physical memory that's being utilized by services. And then the second one is specific to the store process. This is actually a 2010 example, but the same thing applies to 2013. So what you can see is that the amount of physical memory that's running or that's being used by all of the services or all the processes running on Windows at the point in time that we go under memory pressure drops dramatically, pretty quickly too. And that's because Windows is going through and asking every single one of those processes to give back memory. And what it can't give back, it's forcing out to the page file. And you can see store dropping pretty dramatically. We overlay available bytes on there as well. So what's happening there is a bunch of store's memory, which is database cache, is going to the page file. And that's what's causing that spike in RPC average latency. This is what has resulted in quite a few support incidents where users perceive bad performance with Exchange. Customers call in and go through the process of diagnosing performance concerns. They're typically intermittent, and that's because they typically are associated with a VM coming up on a physical host, needing a whole bunch of virtual memory, needing a whole bunch of physical memory on the hypervisor host, and the hypervisor going to the Exchange virtual machine and saying, okay, I need memory, you're going to have to give me some of it, and this process occurring. Yep.
You have split the roles, and mailbox.
So the question is, if you split the roles CAS and mailbox, does this apply to CAS as well as mailbox? This is very specific to mailbox. So technically, the way our supportability guidance is worded today, we just say no dynamic memory. There's a possibility that we may change that to allow it for CAS. We need to do some testing to make sure that all of the CAS processes behave when that occurs, when what I'm describing here occurs. We have seen some issues with CAS not behaving well. We do have other caches in Exchange besides the database cache that can feel pain from this. So currently, this applies to both CAS and mailbox. There's a possibility that it may just be mailbox in the future. So in 2010, basically the same thing applies. We've said as a best practice for many years, don't use dynamic memory, don't use any sort of memory reclamation overcommit technology. And actually, if you go look in both the guidance that Microsoft has published in Hyper-V best practices guides, as well as VMware best practice white papers that VMware has released, they recommend the exact same thing. In general, they recommend leaving I believe they recommend leaving the ballooning driver installed, but reserving memory, basically using reservation settings to lock memory. I shouldn't say lock, because that has a different meaning. Using reservations to guarantee a memory size to Exchange so that essentially the ballooning process won't occur. So another issue that we've been seeing more of lately is around migration. So when you run live migration or vMotion between physical hosts, basically taking a live workload like an Exchange mailbox server and moving it from host A to host B, the challenge there is making sure that throughout that entire process, that virtual machine is reachable on the network by other nodes in the DAG. And the way live migration and vMotion work is somewhat similar for the purposes of this conversation. And at the end of the process, basically the last step in the process of making that migration occur, there's the concept of what we at Microsoft, from a Hyper-V perspective, call the brownout period, where for a very short period of time, could be a second, could be less than a second, could be a few seconds, that virtual machine is actually not visible on the network. It's usually short enough that clients won't notice. But there is a short period of time, guaranteed, that virtual machine isn't going to be available. The challenge for Exchange is that DAG nodes are essentially running in a cluster. We use Windows clustering for a couple of purposes. One of those purposes is heartbeating, to make sure that all the nodes in the DAG are up and running, and that all the nodes in the DAG know whether or not the other nodes are online. So if you actually exceed the cluster heartbeat timeout during that brownout period, then that virtual machine is going to effectively get evicted from the cluster, and a failover is going to occur within the DAG. We're going to take active mailbox databases that were running on that mailbox virtual machine and activate other copies on virtual machines or potentially physical hosts, depending on how you've configured your DAG, that are still online. Because that's kind of it's not really a planned failure, it's sort of ripping out what the workload that was running on that virtual machine at the time the migration occurred. You may actually end up in a case where some of those databases need to be reseeded. I've actually seen that in a number of cases. And that's really the reason that we typically get support calls around this. Someone will go run a live migration or a vMotion, and all of a sudden, everything that virtual machine was doing, it's no longer doing, and all the database copies, or some of the database copies that are on that virtual machine, are now in a state where they can't be used. That's not great. So there's two things that you can do to avoid this. One of them is make sure that the network that's being used for the migration process, for copying the memory, basically between the two physical hosts, is the fastest, lowest latency network that you could possibly build. That's going to really have a great impact on how short the brownout period is. The other potential way to impact this is to adjust the timeout thresholds for the cluster heartbeat. And this describes a way to do that. There's a Hyper-V and Exchange best practices white paper that you can get on the Microsoft download site that describes this process as well. The key here is that you don't want to increase these too much. Because if you increase these too much, you end up with a case where Exchange is going to go for a period of time before it notices that a virtual machine that, or well, really any DAG node has gone offline. And Exchange won't do anything about it until this heartbeat time goes by. So if you set this to a minute, you could rip the network cord out of one of your DAG nodes, and Exchange would just sit there for a minute trying to decide what to do, versus 5 seconds, which is the default, where after 5 seconds it would evict that machine from the DAG and perform the failover as appropriate. So 10 seconds, fine. Once you start going over double the default, you should start to question whether or not you might actually have some underlying infrastructure issues that are preventing this from completing properly. In general, you shouldn't need to do this. You should be able to have that brownout period be under 5 seconds by default. So be aware. Yep. Sorry, I can't hear. Can you speak up? Is there? Okay. Okay, so apparently there's an issue with stretch subnets and a hotfix available from Windows to help with this. So thanks for that. Good to know. And there are, speaking of stretch subnets, well, speaking of subnets generally, in addition to the same subnet settings, there's also settings if you're stretching your DAG across subnets as well, a separate set of thresholds. So this is the default setting, and it's basically 5 pings of 1 second each. So if you wanted to make this 10 seconds, you could change the 5 to a 10, or change the 1,000 milliseconds to 2,000 milliseconds. Either one works just fine. So we talked about snapshots. I'm not going to really spend any more time delving into this. We do see this coming up occasionally from a support perspective. If you are using snapshots in test, just be aware that depending on how long it takes to take snapshots, you can also run into essentially what I just described about DAG nodes going offline for a period of time and getting evicted, depending on how the snapshots are implemented by the particular hypervisor. I've seen this with Hyper-V on 2008 R2, where I have a large DAG. I'm essentially selecting all of the virtual machines in that DAG and saying, take a snapshot. You can end up in cases where, depending on the hardware sitting beneath those virtual machines, you can have some of those VMs kind of go offline long enough that you run into that problem. And then really the last thing I wanted to cover is the notion of general oversubscription around CPU. So just because you can allocate more CPUs to a virtual machine doesn't mean you should. And just because you can allocate more virtual CPUs than you have physical CPUs doesn't mean that you've got more resources than you have in the physical world. And this typically manifests itself in a few different ways. Delivery throughput reduction is one of them. We use a fair amount of CPU to deliver mail. And when we don't have those resources available, we grow queues. Anyone who's run Exchange as an IT pro for a while knows that you don't want to build queues. Having a few messages in a queue here and there outbound to the internet, that's all good. But internal queues for delivering to your local mailbox databases, that can become a painful thing to deal with. You really never want to get into that situation. So avoiding CPU constraint is a best practice absolutely for avoiding that. Content indexing also is a big hog of CPU. CI uses a lot of CPU to do what it does. The challenge with CI is that we want CI to always be up to date. We want CI to be indexing as messages are flowing through the system. The reason for that is that as messages are flowing through the system, they're in database cache. So if CI needs to go get data from those messages, it doesn't have to go to disk to do that. It can get it out of database cache on the mailbox server. If CI gets behind, which can happen if we're CPU constrained, then CI has to catch up. And it does that by going and getting those messages off disk. And we end up using a lot more IOPS than we would otherwise, potentially way more than you would have sized for. So reduced CPU availability ends up resulting in a lot more disk utilization. And then the sort of generic example that I think is probably the most common, if store doesn't have enough CPU to do its job, which is basically to respond to RPC operations, you're going to see pain across the board from clients. You're going to see OA being slow, POP, IMAP, SMTP, Outlook, all clients are going to be slow. Cache mode clients, active sync devices, things that are syncing in the background, it'll be less noticeable. Throughput will be reduced in terms of sending and receiving, but less noticeable to those clients. But any sort of online mode operation, you'll absolutely feel pain. So you want to avoid oversubscribing CPU and reserving CPU for Exchange based on sizing guidance. We also have a workload management component in Exchange 2013 that attempts to balance resource utilization. And what it's doing is looking for peaks and valleys, basically, in CPU. So there are a number of things that in prior releases of Exchange, we used to run as sort of nightly background processes. Things like OAB generation, store nightly maintenance, some of the mailbox assistants that go through and perform operations on content in individual mailboxes. Those are actually now run constantly. And workload management is constantly monitoring CPU and figuring out when there are available resources on the server so that it can then pick times for those operations to run. And then it will stop running those operations, when the workload picks up again, when users start performing more activity against the server. The goal there is really better utilization of hardware, but the challenge is that if the resources sitting behind Exchange are actually dynamically changing, workload management gets confused really easily. It doesn't know how to deal with that. And this actually may impact you more with mailbox moves than anything else. Mailbox moves are actually throttled by workload management now too. So we look for available CPU resources to determine whether or not MRS will actually run mailbox moves behind the scenes, managed by workload management. So it's another reason to reserve CPU resources for Exchange, keep them constant. Exchange will perform much better that way. So virtualization of Exchange 2013, absolutely supported. Please don't walk out of here thinking anything other than that. There are a few limitations. We talked about them. In general, I think the goal long term is for us to remove as many of those limitations as we can within the architectural constraints of the Exchange product. I don't see us changing the way we allocate memory for database cache, as an example. So I don't really see us changing the guidance or the supportability around dynamic memory technologies for the mailbox role, certainly. It's not always the right choice to virtualize Exchange. It sometimes is. It may be for all of you, given how many of you are doing that today. And that's absolutely fine. Don't let anyone tell you otherwise. There is the potential for that balance to change over time. Maybe something you reevaluate as you go through the upgrade process with future releases of Exchange. If I haven't mentioned it already, don't oversubscribe. I think I've covered that enough. And really the last thing is that within Exchange, we've done a lot of work to provide things like high availability, disaster recovery, automated response to issues that are occurring within the product. There are similar types of functionality available at the hypervisor level, but we think that the best level of high availability, disaster recovery, really overall client experience and IT pro experience is going to come from having that functionality integrated at the application level. Because that functionality, that HA functionality, DR functionality, is going to be much better informed by the application itself. Exchange knows what Exchange is up to, can make much better decisions than a component at a different layer in the stack. That's really the key. So that's the recommendation. Use HA from Exchange, use DR from Exchange, use the functionality at different layers in the stack in addition, where it makes sense. So with that, a couple of related content pieces, really all in the modern data center track around new features in Hyper-V. I will be at Ask the Experts tomorrow, so if you have further questions, feel free to come find me there, or come up briefly afterwards and I can give you a business card and we can take things offline. And with that, I will call it good. So thank you very much.